So, Kubernetes rolling update in action. So, what is a rolling update in a specific Kubernetes environment? Updating a pod at a time to prevent service outage rather than updating all of them at the same time. So, let's say that you are deploying an application to the production environment, and if you have a service, you may have multiple pods right behind the service. So when you try to deploy something into production environment, with this strategy, rolling update strategy, this is default, by the way, your pods will be deployed one by one, okay? Because other than that, you will have single point of failure. That means all of your pods will go down at the same time. So that is an undesired behavior on a specific production environment. So this rolling update is the default behavior of the Kubernetes during deployment. This is the main feature here. If we want to refresh our background information that we gained from the previous webinars, that basically you have a deployment in Kubernetes environment, and deployment manages the replica set, okay? In previous versions of the Kubernetes, there were replica sets, but in the newer versions, we got something new, which is called deployments. That is very good, has a good structure to manage the replica sets. So deployment manages replica sets, and the replica sets manage the pod, okay? By using this schema, I will show you an example on the terminal. So keep this picture on your mind. It will help you in the future sessions. So rolling update applied against replica sets. Deployments manage multiple replica sets because it keeps previous version to be able to roll back to a specific version. So that is the reason why a deployment object can manage multiple replica set. Let's say that you have a version 1 of production environment as a replica set, and in order to during the deployment of new version, let's say that version 2, you are doing a deployment. So let's say that you got a problem during the deployment. As a best practice, you need to be able to switch to the previous version, okay? So you need to keep 2 versions at a time at least. That is why deployment manages 2 replica sets during the deployment. It creates a new replica set, and if everything goes well, it deprecates the previous replica sets and use the newest one. That is the main strategy. During the rolling update strategy, we can configure some parameters. There are lots of parameters, but those are the basic ones. Max surge means amount of pods more than desired pod. For example, max surge is equal to 1, means there will be 4 pods at most if desired replica is 3. So here, let's say that you have a service, and that service route traffics to the 3 pods at the backend. If you want to deploy any version to production environment, let's say that there will be created another replica set. At most, you will have 6 pods, right? Because the previous replica set has 3. On the new replica set, you may have 3 again, and in total, you may have 6 replica set of an application. But here, when you provide max search, you will have 4 at least. Why? Because let's say that previous version of the replica set works very well, and then you can add maximum 1 member to the pods here. So in max unavailable section, this is the prevention of the, let's say you are restricting the scaling up feature here by using the max search. In the max unavailable section here, you can, let's say that if you provide max unavailable to 1, you will have 2 pods at the behind at least. Why? Because you have 3 pods behind the service, and then max available is 1. So if you subtract 1 from the 3, you will have 2 at least. So during a specific deployment, you will have at least 2 pods on your Kubernetes environment. As I said to you earlier, max search is for restricting the proportional scaling. So you are restricting the scaling up feature. For max unavailable is for restricting the scaling for service outage. Let's say that if you provide max unavailable is equal to 2, you may have 1 pod at a time. So if you have a production environment that have lots of traffic, you may be down or you may have some service outage on your system. You need to be very careful while you are providing this feature. Here, I provided my feature as a number, but you can also provide these values as a percentage. For example, you can say that, okay, my max search value will be 25% of the entire pods. You can do a rolling update by using replication controller or deployment, but in this session, we specifically use the deployments in order to do some rolling update. If you want to do a rolling update with the replication controller, you can execute the following command here, kubectl rolling update. Just provide the replica controller name here, and then I am providing here my Neve image version. So what actually a deployment means? Most probably you have generated a Neve Docker image and you provided a Neve version. In a specific rolling update operation, most probably you are providing a Neve Docker image here. So for this replica controller name, I am providing Neve Nginx version here. So all the deployments will have same Neve Nginx version here one by one by using rolling update strategy. With the deployment object, you can do something like this. Here, the comment is a bit different than the replica set one. So I am simply using set image function here, kubectl set image, and then I am saying that set the image of this deployment object that is defined by your deployment name here, and set the Nginx image here as the Neve version. So that is simple. In a rolling update scenario, we always change our Docker image version here. That is very simple in the Kubernetes environment. There are lots of topics, by the way, in total, but I will provide you some basic information most used in the production environment. Let's switch to the terminal, expected. So I already execute this command. So if you are repeating me, you can use this command, minikube start. This will create a single node cluster within your local computer. And then when I said this one, I have only one node cluster here on my local computer, and I am using version 1.10, which is the newest version currently. First of all, I will create a deployment, Nginx deployment, which is a version, this one. So here, K is the alias of kubectl. If it is the first time you are joining this webinar, K is the alias of the kubectl. So I am simply creating a deployment object here, and then deployment object name will be Nginx deployment. And then I am providing just the Nginx image 1.11, 1.12, okay? So when I check my deployment objects, as you can see, I have a deployment object here. Have you remember the picture? We have a deployment object, and deployment manages the replica sets, and then replica sets manage the pods. Let me show you in the Kubernetes language here. So I just want to show you the deployment objects. replica set, and then pod. As you can see here, I have an Nginx deployment object here. As you can see, in the RS section, replica set section, you will see there is a hash value here. That means this replica set is the child of this Nginx deployment object. And then when you have a look at here in the pod, this pod is a child of this replica set object. Okay, this is very simple, I think. If you have any kind of question, you can ask. So when you say get po, you will have this running. And then when you make a describe here, okay, as you can see, we have an Nginx image here. Where is it? This one. So we are cool until now. We have a running pod on the system. Let's expose this deployment as a service. So I just want to expose this one. Expose. So I am exposing a deployment. And then just provide a name. So I want to expose this deployment object as a service type, node port, because I'm using local cluster. Node port is the ideal one if you are doing some playground on your local computer. If you are on cloud, you can use load balancer or cluster IP or something like that. I want to export this deployment to the outside on port 80, and then just provide a name, service name here, Nginx service. As you can see here, this is the system service, just ignore that, and then I see the Nginx service. Okay. When I do this Nginx service, it is on the another window, but let me show you this one. As you can see, this is the IP address of my local cluster node, and then this is the random port assigned by Kubernetes environment, as you can see here. Okay. Alternatively, this command is equal to this one. When you say minikube IP, you will get the IP address of the node, and then just append this port number, you will get into the Nginx service. I have an Nginx service, and then behind that service, the traffic route to the backend pod by the service, and you have only one pod. Okay, let's do some scaling operation here. In order to scale your deployment, just do this one, kubectl scale, and then provide your object. By the way, in Kubernetes environment, every deployment, every resource object have an alias. For example, deploy means deployment. Okay. For example, SVC means service. I prefer to use short notation here. So I want to scale this deployment. Just do that. Replicas. So when you do this, get po, as you can see, we have 5 members here. Okay, and also when you say get deploy, you will have 5 desired, 5 current, 5 up to date, 5 available. So everything is okay until now. What about the deploy RS and po? Here, as you can see, we have 1 deployment, 1 replica set, and 5 pods. Okay, so this scaled pod managed by replica set, and this replica set managed by the deployment object. By the way, you can stop me and then ask any kind of question if you want. during the dojo, okay? So let's switch to the rolling update part. Let's say that I want to upgrade my Docker image here, and I want to do that 1.13. So I will set my image as deploy nginx deployment. There is a
అధ్యక్ష పోయిన నెల ప్రవేశపెట్టాల్సిన బడ్జెట్ ఇప్పటికీ అవ్వలేదు. గవర్నమెంట్ నడుపుతున్నాడు అనే స్పృహ.
Sorry, I provided the wrong parameter here. So if you are, sorry, my bad here. I want to update the deployment image here. So first you need to provide your container name here. Okay, nginx is my container name. As you can see here, nginx is my container name here. And then I need to provide this one, because I may have different multiple containers within the deployment object. So I need to provide my container name first, and then just provide new Docker image name and then Docker image version. Okay. When you do this one, as you can see, the deployment object is updated, and let's see the status here. As you can see here, when you say kubectl rollout status, deployment, nginx deployment. So as you can see here, 2 out of 5 has been updated. You can see the incremental value here. So it is updated one by one, and then finally it's finished. You can see your deployment history, rolling update history here. As you can see, we have only 2 versions of the 2 revisions here. So in order to see the status of rolling update, we just used kubectl rollout status. In order to see the history of your rolling update, you can see kubectl rollout history here. So there is a value change cause none here. I will have a look at here in the future. So this is very basic scenario, but let's see the our basic objects here again. As you can see here, now we have only 1 deployment object. We have 2 replica sets because this is the old one and this is the new one. As you can see, the old one has 0 members, 0 pods. And then, as you can see here, this pods is the child of these replica set objects. It is very easy to understand until here, I think. So let's do another operation. In very basic production scenario, you may have something problematic, and in order to make it easy, I will provide a wrong image name for my deployment. So let's say that I will do it something like this: set image deployment. And again, my container name is equal to, there is no such a release, Nginx 1.17. So just do this one. And then again, run this. As you can see here, during the rolling update, you have some error here. You can describe one of them and see what's going on. Actually, this should be something like this. As you can see here, error image. There is no such an image, so fail to pull image, this one. Nginx 1.17 not found. In this kind of scenario, you can do something like this. Just show the deployment strategy here. When you describe your deployment object, you will see something like this. Where is it? Yeah, here you can see strategy type rolling update. This is the default one, and rolling update strategy is 1 max unavailable, 1 max search. So at most you will have 6 at most and 4 at least. Okay. So how can I rescue from this kind of situation here? You can do something like this. Just have a look at the deployment revision here. As you can see, 1, 2, 3, we have 3 revisions here. And I just want to go back to the very first version here. It is very easy to revert back to that scenario. But I will do something like this. I will divide my terminal into 2 sections. I hope you are able to see both of the sections here. So so I'm just watching my system here, and then I will do something like this. kubectl. Just again, my parent function is rollout, and I will do an undo operation here for the deployment object nginx deployment. And I want to undo my operation to revision is equal to 1. So when you roll back your operation here, you will see it will be reverted to the very first version, which is Nginx 1.12 or 13. And then as you can see here, we have successfully rolled back our operation here. But when you have a look at the revision here, where is it? History. You will see something like this none description here. So if you want to see something very meaningful here, you can use -- the record command in order to see which command I actually executed before for this kind of operation. So if you want to clear operation here, let me close this one, deploy rs and pop. As you can see here, I have 3 replica sets, and I switched my replica set to the very first one. And 3 of them are here, and it is not using currently. By the way, you can set the limit of this replica set. So when you reach to the limit, the oldest one will be deleted from the queue. So you can most probably you will have it is very enough to use 3 of them in a production environment, and maybe 2 of them, because at the same time you will use the current version and the previous version. So let me provide an example with the record one. So let's say that I am setting my image for deployment. This time I am providing 1.19, and when you provide -- record here and then try to see the rollout history, you will see you have some meaningful comments here. In order to switch to the specific revision, you can have a look at the change counts here and then see, okay, this is the correct version, I need to revert back. And then by using the -- record, you can see the change counts here. As you can see, there is no such a version here, so I just wanted to switch to the to revision 2. Okay. And that record part was the final part here. So that is all for the Kubernetes rolling update. We just used our command line in order to do this kind of things, but in the production environment, most probably you will have something like the automation tool. For example, you can use the Jenkins in order to do this kind of operation. I mean, deploy and undeploy, or set the specific revision in order to roll back and forth between your revisions. And that was a very basic scenario on the production environment that you can face during your deployment. If you have any kind of question, you can ask, and I can happily answer your questions. So there is one question here. What is the command for applying a new updated version of a manifest? So if you mean the deployment YAML file here, it is very different from the rolling update, because for example, you can use kubectl apply command and just provide your manifest file by using -f parameter. But keep in mind that you cannot apply all the fields in a specific deployment specification or manifest file. You can do something like this. You can do kubectl edit and then edit your manifest, and then just save your file. It will be replaced. But at the same time, you can do something like this. Just delete your deployment and then reapply your new manifest file. If you are changing your image, it is okay. But if you are changing something like in the more parent section, if the YAML file, you will get something like, okay, you cannot change every field within the deployment YAML specification file. Just create a new one, and then delete the old one, and then apply the newest deployment file there. But if you are changing your deployment manifest, it is something like you are changing your architecture. For example, you are changing your deployment API version there. So if you are changing there, it is something like architectural change. So you need to design that first, test very carefully, and then delete the old one and apply the newest one. That is the main strategy. But I don't mean this one, by the way. Just delete your deployment and apply your new deployment file. This will cause some outage on your production environment. Instead of doing that, you can do something like blue-green deployment. Okay, in blue-green deployment strategy, you will have your old production environment and just apply these new deployment files on the separate environment. It can be something like prod 1. Okay, once you deploy all the thing by using new manifest file, you can delete the traffic from the old deployment environment, and then you can route all the traffic to the new deployment manifest file, the environment created by the new manifest file. But a new manifest file cannot be done by using rolling update. Any other question? Actually, I mean, if you simply want to version control it, you can do something like this. By the way, I used the literal commands here, interactive commands here in the terminal, but in production environment, most probably you will have deployment specification file, YAML files, and then yes, you can change your image version and then do simply kubectl apply, and your deployment will be in rolling update strategy by default. That is the desired version, by the way. And yeah, you can do that by using kubectl apply. But I mean this one. Let me show you one example here. So here, if you change something like here, template label, or something like in match labels, etc., you need to do something like replace other than just apply, because Kubernetes will not allow you to update every field here. But if you are changing only the image version here, yes, you can do that. In most scenario, we are replacing the Docker image version here with the newest one, as you said. And we are storing this YAML specification file within the current application. And all of them are in historic way. Any other question? Okay, I think that's all. So if you have any other questions, you can ask me on our Slack community Slack channel. You can send me an email, whatever you want. You can ping me on Twitter, GitHub, whatever you want. I can happily answer your questions. And yeah, we will decide the next topic within 1 or 2 days, and then see you on next week with the new fashion topic on the Kubernetes environment. Okay, thank you all coming to this session, and have a nice evening. Bye.